Hey everyone, this is Math Done Right, and today we're going to be finishing up part 3 of System of Equations. This time we're going to be working with no solutions here. We got none, zilch, nada, no solutions for these systems of equations. And let's remember that we're going to be solving multiple equations with multiple variables simultaneously. One of the points of trying to solve a system of equations is trying to figure out where two lines are intersecting with each other, and in parts 1 and 2 I had two lines intersected once with each other at this point right here, or they were on top of each other and we had infinitely many solutions. And so now if I have no solutions, it means my lines are never going to cross with each other. And the types of lines where that happens, there's a specific nice type is going to be parallel lines. Right? We know that parallel lines don't intersect with each other, and if I were to graph some parallel lines, just for example, this is what they would look like graphically. So this would be, I'm going to call this line 1, and then let's call this orange line line 2. They're parallel lines, they never intersect each other, so that means there would be no solutions for this system of equations. So if I were to take this system and transform the equations into a linear equation, let's remember that a linear equation is y equals mx plus b, and m is my slope, and b is the y-intercept. For two lines to be parallel, the slope is the same. So slope is same, but the y-intercept is different. And if I look at these two lines, for example, well, I can see that the slope is the same, right? The level of which they're increasing is the same, but where they cross the y-axis is different, right? I have a y-intercept down here and a y-intercept up here. So I have the same slope but different y-intercepts, and that gives me two parallel lines. So what I'm going to do for my first example is take my equations and show that I'm going to get the same slope but different y-intercepts. For this first example, let's look at this system of equations. Negative 2x plus y equals 4, and 4x minus 2y equals 3. So what I want to do is try to show that these two lines are parallel to each other. So I have to solve for y in both of them. Well, let me call this line 1 and this line 2. So let's go ahead and work on solving for y in line 1. So I'm just going to copy it down. Well, that's super easy. I can just add 2x to both sides. That gives me that y equals 2x plus 4. Now, in order to have the second line be parallel to this, I better have an m value here of 2, a slope of 2, but then my y-intercept needs to be different. So let's look at that second equation. I have 4x minus 2y equals 3. I'm trying to solve for y, so I'm going to subtract 4x from both sides. That gives me negative 2y equals minus 4x plus 3. Now I'm going to divide everything by negative 2, and that gives me y equals negative 4x divided by negative 2 gives me positive 2x. And then plus 3 divided by negative 2 gives me a minus 3 halves. So that's my second line. So I do have that m is the same. So if I look at m here, so m is the same. But then I compare the y-intercepts. The y-intercepts are different. So automatically I know that I have two parallel lines, and I can kind of graph what they would look like. I don't know if it's going to be, you know, Picasso over here, but I'll try my best with just a little freehand action. So I have a y-intercept of 4 and a y-intercept of -3/2. So let's say that's -3/2. And I have a slope of +2. So I know one of them is going to look like this. Let's say that's line 1. And the second one is going to look something like this, going through the y-intercept -3/2. And, you know, assuming my drawing's correct, let's say these two lines are parallel, and we notice that they don't intersect each other. So in terms of this system, what that really means is that no ordered pair x and y will ever satisfy both of these equations simultaneously. Maybe I can solve one of them, but I can't solve both. And remember, that's the goal here. I'm trying to solve multiple equations with multiple variables simultaneously. And I cannot do that in this instance right here. Alright, so let's try to do this again with a different example, but in a slightly different way. So my first equation is going to be 6x plus 3y equals 12, and 2x plus y equals 1. Now, if we try to solve this like a regular system of equations like I did in part 1 of my videos, I'm going to use substitution because it's easier in this case. So I want to look and see, okay, which equation is easier to solve for one variable, and that'd be the second one. I can solve for y pretty easily. And that's going to give me that y equals -2x plus 1. So, just like I've done before, I'm going to take this y and shove it into here. Now, once I shove it in there, I'm going to get 6x plus 3 times my -2x plus 1 equals 12. Now I have a linear equation in x, I can try to solve for it. So this gives me that 6x. Now I have 3 times -2x gives me -6x. 3 times 1 gives me +3 equals 12. Okay, well I have 6x minus 6x. Bing bong, those are gone. And what I'm left with in the end is that 3 equals 12. Super weird. Now, the question for you guys is 3 ever equal to 12? And any person on the street would say no. That's never true. Never true. 3 exclamation points here. So when we get something that looks like this, and what I mean by this is I have one number equal to a different number, that's where I get no solutions. So in part 2, when I had infinitely many solutions, I had one number equal to the same number. That gave me infinitely many solutions. But for no solutions, I need one number equaling a different number, and that will give me the no solutions that I'm looking for. Okay, well, that's all I have for you guys on solving systems of equations. I've done 3 parts now, 1 solution, infinitely many solutions, and no solutions. Make sure you check them all out. If you have any questions, just leave them in the comment section. Make sure to like and subscribe, share with your friends, professors, teachers, fathers, mothers, daughters, sisters, cousins, lovers, whoever you want to. Alright, thanks for watching. Bye.